let's talk about these proofs we have. First one's running to exactly one line. Any questions about that one or what it means? And that when you make two, it basically means that if you put two dots on, there's only one line that you can draw through them. Okay? For any non-collinear points, there is exactly one plane. Be true. Okay, they've been proven, they're true, no matter what. Wake up. So, for any non-collinear points, meaning they're not on the same line, these 2 points. Well, basically what this one says is that since 2 points determine a line, a line's got to at least have 2 points, doesn't it? Because that's what determines a line. A plane contains at least 3 non-collinear points. Same thing as this, since 3 non-determines a plane. If 2 points line a plane, then the entire line that contains those 2 points line a plane. So if the 2 points line the plane, the only line that you can draw that connects them has to also be in that plane. Accept them to be true. And you can use this postulate to justify saying this. You know, you're out and about, hanging out with friends, and they start talking about 2 lines intersecting. You can quote postulate 2.6 that says that, and you've got a picture of it. Or one theorem. Theorems, if M is the midpoint of AB, then I can say that AM is congruent to what? Okay, so those are the theorems I had you write down. They're pretty self-explanatory, they're pretty understandable. Now, what you're going to find is that what you're going to do a lot in geometry is we're going to give you some postulates or axioms, and then we're going to is this right here. List the given information. Okay? That is stuff that's accepted to be true. So in a problem, if they say this, this, and this have happened, that is when we do proofs on the board. This is given to us. Then they want you to prove this conclusion down here at the bottom. They want you to prove something. Well, the hard part is figuring out what to put in between. And the thing that you'll have to do here, this word right here, justify, like you write it as a sentence, you just kind of write down what you're thinking. Okay, these 2 points connect to make a line because of postulate 2.1 says that. And then you go on and state your next part. It's not as formal as what mostly we're going to do, which are 2-column proofs, which we'll do in the next section. But here's an example of a paragraph proof. Isn't that basically what you just went through in your mind when you looked at that? Okay, write that down. And that's what they did. If M is the midpoint of xy, then the definition of midpoint of a segment, we know that xm is equal to my. You just have to write it more with geometry language. This means that xm and my have the same measure. So they stated what that meant. You may have to go that far, you may not. By the definition of congruence, if the 2 segments have the same measure, then they are congruent. Like I said, I won't even say it as elegantly as they did. But I'll get the point across. I'll justify my statements, and I'll lead from one to the other. Now, what I want everybody to do is get their little red books out. Let's start looking at some examples. What we're going to try to do is try not to throw, the last 2 problems in this assignment are the ones that are actual proofs. What a lot of these problems are going to do in between is try to get you to work towards that. That contradict something that we accept to be law and true?
Yes, never.
Yes, it does, so never. You see what I mean? How it was directly the opposite or contradicted something that we say that has to always be true? So that's why it's never. When you go to extremes of black and white, it's probably either gonna be, something that's given to you, you know how they say the world's black or white? Okay? You're probably gonna have the exact opposite or something like that. Linear point, non-linear points R, S, and T are contained in exactly one plane.
Always.
Why is that?
Always, because 2.4, or yeah,
Postulate 2.4,
2.2.
2.2. It says that for any non-linear points, they're exactly one plane. Yeah. See how we had a postulate to back up always? That's part of the logical process, the way you need to think. You need a postulate to back up always. Or the exact opposite of it to back up never.
Sometimes.
Oh, the partial.
Never.
Oh.
Now, like I said, if there was I told you guys rules as far as contradicting, but that's not always gonna, you have to think about it. Can you think of a time when that does happen?
Yes.
Here's my thing here. Sometimes there is a little bit of interpretation to this. Are they all have to be on the same plane? See what I'm saying? That basically, in essence, that's a proof you're writing down right there. You're saying, okay, first, because when there's more than one step, you're saying, okay, first, since A, B, and C are non-collinear, this postulate says that they have to be in the what? Same plane. Then, you would say, since A, B, and C are on the same plane, or A and B are on the same plane, line AB has to be in that plane too. And since BC are on the same plane, BC has to be in that, and so on with all of them. Therefore, you come to the conclusion that they're all then have to be in what? Exactly the same plane. So the answer here, always. Looking at right here, state postulates that can be used to show each statement is true. Exactly one plane contains F, B, and E. And the measure of angle D is equal to the measure of angle E, right?
Yeah.
We okay there? By the definition of congruency. And you'll see that I abbreviate a lot in my proofs. By the definition of congruency. Congruency says that the measures are the same, right?
Yeah.
Which are 30 and 31. These proofs, you are to try those proofs before you even start on 1 through 29. I want those done when you walk in this door tomorrow. I don't care how terrible your proof is. I don't care how disjointed, how much it doesn't make sense. Give me an effort, something about, a paragraph. Try to write a paragraph proof. We will then do those two proofs, but we will then, I will check all of you for a 5-point grade tomorrow, whether you did those two proofs. This actual 1 through 29 will not be due till the first of next week, because we're going to do a section, do proofs from that section on the board. Do a section, do proofs from that section on the board. You see what I'm saying? It's going to be a slow process for the next week. Everybody understand that?
Yes.
So what do you have to have done before you get